Good morning. Since we're having the ducking cover drill today, I decided to make a video in case we run out of time so that we don't end up losing more time. I will also be making a video for Thursday's lesson for those of you who are missing again for NISMA. So today we're going to talk about measuring angles and arcs in a circle. So there are several different types of angles in a circle. Today we're going to focus on what is called a central angle. So a central angle is the angle with the vertex at the center. So the sides of the angle will always be 2 radii. The degree is 1/360. So degree by definition, you know how we measure angles in degrees. It's by definition is 1/360 of a circular rotation about a point. That's why a circle is full 360. The sum of central angles with no interior points in common, or in other words, adjacent angles, is 360. So here I have 3 interior angles. If I add them together, I get 360. Again, reminder, with videos you can always pause and rewind and etc. So now arc. An arc is part of a circle, or a circle defined with 2 endpoints. So there are 3 different types of arcs. We use arcs when we do constructions. So there is a minor arc. Minor arc is pretty much the shortest arc connecting 2 points, and it's always less than 180. That's the important thing here, is less than 180. And the measure of an arc is equal to the measure of the related central angle. So if we look here, you see that I have angle X. It is the central angle that sides create the arc AB. Therefore, the measure of AB is equal to the measure of angle ACB, or X. There's also a major arc, which is the longest arc connecting 2 endpoints. So in this case, I have the same drawing, but here I'm going around the outside. How do we differentiate? We add this 3rd point in. So the major arc would be arc ADB, and that's indicating to go the long way. The measure of a major arc is 360 minus the measure of the minor arc, or that central angle. So in this case, it's 360 minus X. And then, of course, a semicircle, which is where the 2 endpoints are on a diameter. Here they added the 3rd point. You don't have to, because it doesn't matter which way I go. They're both equal to 180. Here are some theorems. Now again, with circles, we're not really so much focusing on proofs. While we will do some proofs, our focus is mostly on calculating things. But there will be proofs on your test. In the same circle or congruent circles, remember congruent circles just have the same radius, 2 minor arcs are congruent if and only if their central angles are congruent. Adjacent arcs are arcs in a circle that have exactly 1 point in common, or they're formed by adjacent central angles. Because if the central angles are adjacent, so will the arcs. Sorry about the announcement. So arc addition postulate is very similar to the angle addition postulate. The measure of an arc formed by 2 adjacent arcs is the sum of the measure of the 2 arcs. So here's what we're talking about. 2 different things here. Let's switch to white. So if I have a circle, and I have this diameter and this diameter, so that these are central angles, we know that angle X and angle Y are congruent because they're vertical angles. And since angle X and angle Y are congruent because they're vertical angles, and those are the central angles of arc AB and arc DC, I can say that arc AB is congruent to arc DC. Now using the same diagram, I can say, so let's call this circle O, I can say that the measure of arc AB plus the measure of arc BD is equal to the measure of arc ABD. And that's the arc addition postulate. Because AB and BD are adjacent angles, or adjacent arcs, sorry, they only share a point B that's on the circle. Arc lengths. So we've been talking about the measure. The measure is in degrees, and it's equal to the central angle. In order to calculate the length of the arc, we have to take into account the circumference of the circle. So the ratio of the length of an arc, L, to the circumference of the circle is equal to the ratio of the degree of the measure of arc over 360, because a whole circle is 360. So it's pretty much the proportion, L over 2 pi r equals x over 360. Or I like to think of it in terms of an equation. I'll do L is equal to the central angle, or the measure of the arc, over 360 times the circumference. Either way is completely fine. And like I said, I typically use this one. So now here are some examples. I would like you to pause the video and do the 3 examples, and then come back and I'll reveal the answers. So welcome back. So this one, I'm looking for the length of the arc. So if I want to do the length, again, what I do, I won't switch to white, is I do L equals the measure of the arc over 360 times the circumference. So the measure of the arc is 45 over 360 times 2 pi times 3 in this case. I do that calculation, and my answer is 2.36 to the nearest hundred. Here again, I'm looking for the length of arc AB. So yet again, I use this exact same formula. However, in this one, it's AB over 360 times 2 pi times 7, because I only want to use the radius. The diameter is 14. I do that calculation, and it's 9.77. The last one, again, I'm doing the same formula. So it's 120 over 360 times 2 pi times 8. I perform that calculation on my calculator, and it's 16.76 feet. Notice the length of the arc is in centimeters, meters, or feet, just like circumference. The measure is in degrees. Radians. We switched your calculator to degrees earlier in the year. Now we're sometimes going to have to talk about radians. So you need to know that radians is another way of measuring an angle, and that 360 degrees equals 2 pi radians, or some people like to say that 180 degrees is equal to pi radians. It's just a conversion factor. So if you have, say, an angle that's 30 degrees, I can find out how many radians that is by doing 30 over 180 equals x over pi. We always give radians in terms of pi, so this is 30 pi equals 180x. Divide by 180, and x is equal to pi over 6 radians. So 30 degrees equals pi over 6 radians. They will give you this conversion on your reference sheet for your regions. I will not. So that is the end of 10-2. Your homework tonight, which is on the back board or on Aspen, is page 710, numbers 13 through 51, odd, 52, 56 through 58. And I apologize, this is Thursday's lesson, not Wednesday's.